Okay, this is just going to be a quick video explaining operators, and you don't need to write any of this down. This is going to be just to help me explain operators. So for example, if we take this as an operator and operate on the function y of x, it just gives us this. And operators basically are just shorthand notation for performing a bunch of, well, not a bunch of it, just performing like operations on it. And it's just so that you don't have to write everything down. And like, let's say we operated on y of x to get that, and then we can then substitute in the d equals ddx and then dy equals y prime and then all of that to then get it in terms of d, which gives us this. So that's just an example of an operator working, and that operator operating on y of x to get all the way through here. And then you don't exactly need to know how it works right now. It's pretty straightforward. It just simplifies things down so there aren't that many things on the paper. Another example would just be a first degree polynomial operator, which is d minus a, and operates on y equals y of x. And that gives us, parentheses, the quantity of d minus a y, which simplifies to this. And the whole point of this video is just to show that if you want to understand why theorem 2 works, it's mainly because there are, like for example, if we have a problem with the roots 1, 2, 2, 2, 2, 2, there's just a bunch of 2's, and we only have end up with the functions e to the x and then e to the 2x, but there's just a bunch of ones that we left out. And that's where theorem 2 comes into play, where you just add in the x's. And basically, page 164 and 165 introduce us to operators so that we could, well, it proves what theorem 2 does, and it shows that there are a bunch of different properties of operators that we could use to basically prove theorem 2. So if you want to look behind that, you can read the textbook, but I will not really go into the proof of that.